So now we're going to discuss the actual derivatives for the natural exponential function. And this is one of the simplest and smallest derivative rules for any function. We see that when we try to take the derivative of the function e to the x, its derivative is simply itself. It's equal to e to the x. Now what that also means is if we try to take the derivative of e with a function in its exponent, like e raised to the f of x power, we're going to keep the e to the f of x power. That part's not going to change. But since there is more up above than just a regular x, we will basically have a chain rule situation where we have to multiply by the derivative of what's on top. So here we're going to take the derivative of y equals e to the tan x. So we're trying to find y prime. So up above, so this is e raised to the tan x. When we take the derivative, we'll keep e raised to the tan x. That part doesn't change. But we still have to multiply by the derivative of what's on top. And so the derivative of the tangent is secant squared x. So what we just did here is we have the first part is e to the f of x, and this other part is f prime of x. And really there's nothing else to solve or simplify here. It's just a matter of, usually we like to put secant squared x first, follow that by e to the tan x. But either way is equally the same. So this one is e to the negative 4x times sine of 5x. To take the derivative of this, we'll have to look at the two different parts. The first part and the second part. Each part is being multiplied together. So from the very beginning, we're going to have to apply the product rule to this. So y prime is going to be the first e to the negative 4x times the derivative of the second. The derivative of sine of 5x would be, derivative of sine is cosine 5x times the derivative of what's on the inside of that, which would just be a 5. So again, what we just did here is first, derivative of second, then we do the next step, which is the second. So we go plus sine of 5x, and we multiply that by the derivative of the first. Derivative of e to the negative 4x would be e to the negative 4x, but then multiplied by the derivative of what's on top, which would be negative 4. So at this point, it's just a matter of trying to simplify it a little bit. The first part, you change that into 5e to the negative 4x cosine of 5x minus 4 e to the negative 4x sine of 5x. Okay, so this one I have to take a little bit more steps with, mainly because I now have both numerator and denominator. So that's going to involve the quotient rule to get started. Okay, so here we're going to find f prime of x, and let's go through the quotient rule. Quotient rule goes low, x squared plus e to the x, d high. Okay, well, d high, how are we going to find the derivative of the top? Well, notice that those are two things multiplied together, so for the top, we're going to have to apply the product rule for those two things up on the top. So low, and then d high. D high is going to go x squared first times the derivative of the second. Derivative of the second is just e to the x plus the second e to the x times the derivative of the first. That would be 2x. Okay, so now we've taken care of the product rule for the top part. Let's continue with the quotient rule. Low d high minus high d low. And the d low part will start with 2x for the derivative of x squared, and then derivative of e to the x is still just there as e to the x. all over the square of what's below. Okay, so now we finally set this thing up in a way where we've taken the derivative by the quotient rule and by the product rule. So now it's going to be a exercise in trying to simplify this thing down as much as possible. Do a couple things here. One thing is I'm going to distribute this into the parentheses, and so we're going to have here x squared plus e to the x times x squared e to the x plus 2x e to the x minus 2x cubed e to the x minus x to the second power e to the 2x all over x squared plus e to the x all squared. Okay, curious thing is now I'm going to actually do some kind of crazy. I'm going to FOIL out these two things in parentheses. What I'm trying to do here is see if I can't combine some terms and reduce it down some. So here are the connections I'm going to make. Here are the multiplications I'm about to make. Same thing as if I was FOILing it out. So the first one would go x to the fourth e to the x plus 2x third e to the x plus x squared e to the 2x plus 2x e to the 2x. That's going to be what's there after FOILing it, and then we have minus 2x cubed e to the x minus x squared e to the 2x. Alright, well this is kind of getting crazy, but the reason why we did it can now actually start to show up. And notice how we have a positive 2x cubed e to the x and a negative 2 of that same term. So those, I can cross those out. Should be something else we can cross out. Here we can get rid of the x squared e to the 2x and the negative x squared e to the 2x. So while it did take a lot to write that out, it does go ahead and take care of some of these extra terms that we don't necessarily have to have. We'll go ahead and write this as x to the fourth e to the x plus 2x e to the 2x all over x squared plus e to the x all squared. And that should be all that we have to do in order to simplify this one down.